Welcome back, and in this tutorial we're going to discuss how to do various networking things in HappyBrackets. We're going to start by talking about OSC, and then we're going to start looking at how HappyBrackets makes a whole load of stuff with OSC and networking very quick and simple and convenient, and then we'll step back and we'll actually look at more standard approaches to OSC. So as before, I'm going to open an IntelliJ project which I've already set up on my desktop called HBTute, and I've already imported the IntelliJ project files, the HappyBrackets examples files for this project, tutorial 6 in this case. Okay, but again we're going to start from scratch. I've already got one device running, an external Raspberry Pi, and we're going to start from scratch again, so we won't actually look at those tutorial files, but they're there for reference and we'll be recreating those files. So I'm going to create a new file, HappyBrackets sketch, and just put network experiments. And you can follow along, or you can just listen and then look at the tutorial 6 example files. So standard template here, got the HB reset command. Okay, so we'll look at a couple of examples and then we'll discuss what's actually going on under the hood. So firstly, I'm going to create an hb.controller listener, and what I'm going to do is add a controller listener. So using autocomplete, I've just typed in controller, or I could type add and CON, and I'll get the option to complete this and get add controller listener. And what goes in here, if you remember, you can hover on here and click function F1. That gives you the documentation, and you can see that the argument that is needed for a controller listener is an OSC listener. This comes from a library that we didn't create but that we're using in HappyBrackets by skis.de. It's one of many libraries for the OSC protocol that are implemented in Java, and we'll talk about that in a minute. So what I'm going to do is say add controller listener, new OSC listener, and that gives me, automatically throws in this function. So basically I'm making my sketch listen for incoming messages, which are this kind of object, and what this has given me is an anonymous class. So it's a class that's just being created on the fly, and we're implementing the message receive function. So we're saying basically what should happen when a message comes in. So what comes into that function from the outside world, a message coming over the network into this function, is three things: an OSC message object, and then the address of the thing that sent it, and there's also a timestamp, which we're not going to use. So let's just ignore the content of the message, and let's just assume that a message has come in, and I'll just say HB status, set status, hello, OSC. Okay, so all I want to do is just check that a message has come in. So I'll recompile this. I'm going to send that to my external device. Okay, external device, running this code, nothing happening. What a controller listener does is actually quite specific. Up here in the HappyBrackets plugin, we have a little command prompt, and we can type anything we like, and we can send it to either all devices or the currently selected device. So at this point it doesn't matter, I'll say all. And so this message here has been sent to the device, and as you can see, this line of code has been activated. Hello OSC. So we'll do something a bit more interesting. We'll actually look at the message and respond accordingly. I'll say if OSC message get name. So that returns, every OSC message has a name, or actually technically the term for that is an address, an OSC address, but it's a string. That's the important thing, it's an identifier string. So OSC message get name equals, and we'll just say play. I'm going to make a thing that plays some sound. There's a convention in OSC. We don't have to follow that convention, but it's good to get into that habit. There's a convention in OSC that you make your names follow this slash terminology. So we might make more complicated names like play my sound. That's why we use that convention. It looks a bit like a file path, but for now we're just basically putting in a string called play. Let's play a sound when that happens. So we'll just play one of our existing samples. So we might say, I'm going to actually load this sample here. Sample s equals sample manager, sample, and then data audio. We can remind ourselves where our audio files are. I'll play a guitar sound. So I'll say data audio nylon guitar clean a arm.wav. So I've loaded a sample there, and here I'll just say hb.sound new sample player s. Okay, so the message play comes in, and it's going to play a sound. Okay, so let's load this up, recompile, send the code over. The code is now running, and if I send this again, nothing happens. Sending a message, send a message. Now if I send the correct string, and that's playing on my external device here, so you can probably hear that through my microphone. So that's playing that sound. And we should also be able to run the simulator, running on my local device, and I'll send this to all now, send that to all devices, and I can say play. And I'll just reset, send to all devices, and let's press play again. So you're hearing that sound playing on two devices. You'll hear they don't play perfectly at the same time. There's nothing that establishes that they should play at the same time, especially because one of these devices is actually running on my local machine. So there's absolutely no network hardware that's involved in getting that message to it, but it still receives the network message even on a local machine. So we're hiding all of the network complexity here, and the only reason we use add controller listener is to listen to messages from the controller. Remember, the controller is our host machine. Okay, so we can play a sound, and we can also, just for example, we might say play guitar as one message. Instead, I'm going to have extra arguments in the OSC message. Okay, so we could use different strings. We could say play guitar, play piano, play saxophone. Instead, we can also add additional data after the string. So let's just say we wanted to say how fast to play back the guitar. So we might want to play it at regular speed, or we might want to play it at double speed, 1.5 times speed. Okay, so we're going to look at the additional content to this message. So I'm just going to pull out my sample player. Okay, so that's the same code. It's playing the sound. The sound is based on the sample, and I can say SP set rate. I can say SP get rate, set value. Okay, so I want to set the value, set the speed value there. So an OSC message comes in. The OSC message has arguments. What that means is, just like a function has arguments, this function has an argument for OSC message, socket address, etc. The OSC message has arguments. So the string, the name, is the first part, and then everything else after that are arguments to the message, and they can be of the basic primitive data types, ints, floats, strings, and they can actually be of any complexity, but we're not going to deal with that because we're only entering strings in here. We're not going to be typing in complex objects. So I want to be able to put a float in here, so I can say OSC message get arg 0, which means get the first argument. And actually, this OSC message object can contain arguments of any kind, of any object. So we're going to cast that to a float. In other words, we're feeling lucky. We're confident that that's going to be a float. And let's just see that in action. I'll recompile. And I'm going to say play guitar 1.5. And I'll change it to 1.7, 1.2. So that's working. The float argument, it picks up that the first argument is supposed to be used as the rate. There's nothing that tells it that. This is just your own convention. So you're deciding that the first argument is a rate, etc. Now we can add additional arguments, and we could get those by saying get OSC message get arg1 instead of get arg0. There's a catch here. If I put the number 1, which seems like a reasonable thing to do, and send that, it's going to blow an error. You didn't hear any sound there, whereas if I say 1.5, you do. If I do send 1 or 2, nothing. The problem is that the OSC library is expecting a float. It's trying to force it to a float, and it's not happy about that. There's a convenience method. So what you can do is you can actually write some code that goes through and checks whether it's a float, checks whether it's an int. This is an int, so that's why it's not understanding it. Well, we've just added a convenience method for HappyBrackets, which is HB get float arg, and then we add the OSC message, and then we add the argument. And what that does is it just basically it turns anything into a float that it can. So it will also turn the integer into a float. That's just a convenience method to save you some more complex parsing. So I can now send in some floats. So that's the anatomy of an OSC message. So again, you could continue grabbing different arguments and using that index, which should specifically refer to the position of your arguments in the list. And at the beginning of the whole thing, you've got a name, which is a string, which you can parse. Just a couple of other pointers there. Okay, so one really important thing is actually, you'll notice that this line says equals. It doesn't do this, which is what you might expect to do. This is a gotcha in Java code, because the equality, this actually wants to see whether this string points to the same space in the memory as this string does. That's not what we're trying to do. We're actually trying to compare the strings. So this equals function is actually comparing the strings to see if they're equal. We can do some tricks. We can, maybe if we're worried about getting the case right, so if I said play lowercase guitar like that, we could do a trick. We could say play guitar. We'll just make this lowercase, and then what we'll say is we'll say OSC message get name to lowercase. Okay, so that just means that whatever comes in, we force it to lowercase, and then we only bother doing the string comparison to lowercase. If I recompile that, send that, then I can do this, but I can also do any case sensitivity is not a problem anymore. Whereas if I hadn't done that, then that would be a problem. So we might want to do things like that. We could also say, instead of saying equals, we could say starts with, and that would mean that I could add some rubbish on the end of here, and it would still recognize that as play guitar. This is entirely up to you how you manage things. We don't dictate how you should do that. This interface also lets you can press the up key, and it goes back through all of the messages sent. So this interface is kind of like one quick and easy way that you can just send OSC messages, test OSC messages. And actually what's quite nice is that you can just quickly change that. Once you've got your thing parsing OSC messages, you could say HB add broadcast listener instead of controller listener. And that's what we'll be looking at next. So a broadcast listener listens to broadcasts that come from anywhere. The controller listeners just listen to messages that are coming from the controller. Behind the scenes, there are different ports and things which we'll talk about in a minute. In fact, what I'll do is I'll make an independent OSC listener. So that's now an independent object that does the behavior, and then I can see HB add controller listener, my listener, and HB add broadcast listener, my listener. Okay, so this code gets evoked wherever the message is coming from. So we have the anatomy of an OSC message. An OSC message consists of simply a string followed by any number of arguments, which may be ints, floats, booleans, strings, actually any data type, but largely we just focus on sending those primitives. An OSC listener gets activated. This message receive function gets activated whenever an OSC message arrives, assuming, and we'll look at this behind the scenes, we're making sure that we've got something set up listening on the right port. And in comes an OSC message, an address which tells us where the message came from, and a timestamp. So with that, you can basically write a lot of stuff. Okay, in addition, we've shown that we can have a controller listener, which responds just to these messages typed in here, which is mostly for debugging, but you could use it for live performance as well, and broadcasts from anywhere. Where did these broadcasts come from? Well, we can actually do that in our code here. Anywhere we like in any HappyBrackets sketch, we can say hb.broadcast. So anywhere we like in any program, we can also send these broadcast messages. And within the local network with your devices, broadcast will broadcast, and anything with a broadcast listener will pick that up. Again, just to reiterate, we've simplified a load of stuff here that would require a little bit of extra code to get set up, and at the end of this tutorial I'm going to show doing this thing from first principles. So let's actually go through this. What we'll do is I've got this code now listening to broadcast listeners and controller listeners, and I'll just make a new piece of code, a new block of code here. So this block of code I'm just going to rename as, I'll say refactor, rename example listener, and That was a refactoring operation on the function. Now I need to actually just check it's given me some warnings. I'm just going to hit do refactor. That's renamed to example listener. And I'm going to make a new class, another HappyBracket sketch called example sender. So I'm going to broadcast something here. I'm going to say HB broadcast, and then all I need to do is enter the name, which is play guitar, and any arguments I want to add. So this is exactly the same as typing this stuff in here, except I put them into a function. And if I had multiple arguments, that's okay too, but I need to make sure I get it right. So this example is listening. It's expecting a message with the name play guitar, and then it's expecting one argument, which in this case can be an int or a float, and it will play back a sound when it gets that argument. This code is using exactly that string and sending one argument. So things will actually crash, they'll go wrong if I don't include that argument. If I include extra arguments, no problem, they'll just be ignored. If I get the name wrong, no problem, just means that this code won't run because it won't pick up on that. So I'm going to recompile this, just reset both of these, recompile this. I'll send this one to my host computer, that's the listener, and I'll send the sender, and as soon as I send the sender, it will receive the sketch and it will send this over. So as soon as this one receives this code, it will trigger this one to play. So you hear the note getting played on this device. And what I can actually also do, if I send this code over to here as well, both of these are playing the receiving code. From here I'll remove the reset function, which means that it won't clear the listening code from here. Otherwise nothing would happen because it would get cleared. Now I'll send this over. That sound is getting played from both devices. So you can broadcast to yourself. You can send an internal message to yourself, which is important to understand. So if we go and look in the tutorials, we've got the controller listener, and in this case our controller listener is playing a wave oscillator, a sine tone, through a gain control which is turned down to 0. So the volume is turned down to 0 in this line. The controller listener listens out for the message play, and it also checks to see if there's an argument. If there's not an argument, it just ignores it, but if there is an argument, it will set the frequency. Otherwise it will just play the sound at the previous frequency, whatever frequency it was set to at that time. So you can see that our wave player has its frequency set, starts at 500, and then it plays a bleep. It has a little envelope which plays like a long 1 second tail. And we've also got two other messages. If we get the message square, then it will change it to a square wave. Sine, we'll change it back to a sine wave. So let's run this. This is a controller listener, so I'll send it to the internal device again. Just turn down the volume, and I can say play. So it just plays that tone. I don't need to put an argument, but I can if I want to. Very low frequency, can't handle it. Okay, so we can do that. We can say square. Nothing happens because we don't hear anything, because there's nothing actually making it play any sound. It's just changed that to a square wave. I can hit the up key to get back to my 200. Play that. Play some other frequencies. Okay, so that's the controller listener. Now I can reset that. We can also look at this other example, broadcast sender and listener. This time it does the same thing. It's got this wave player that's muted. This time we create a clock, and that clock is running at 500 millisecond intervals. 1 in every 10 chosen at random, it will play a sound, but it will also broadcast to the other devices that are listening on this network. And it will send the bleep message, and then it will also append as an argument, it will send its own index, which is the index assigned to the device by the controller here. Okay, so the index is set. It sends its own index, and then it also is in the same code, it's listening for broadcast messages. When we get this bleep message, we'll play a sound, we'll turn up the volume and fade it out slowly. And we're filtering using the argument, the first argument, which is the index. We're filtering out any messages that actually came internally. So we're using that index thing. We're saying, if this message has the argument with the same index as me, don't play a sound. Otherwise, do play a sound. That's just a quick way for every device to respond to external messages, but not internal messages. We could also do something where we checked the address, but that's a little bit more complicated. So recompile that. And now if we send that to, reset these, send that to both devices, so send to all devices. So what you're hearing there is a short bleep being echoed by a long bleep and happening once every so often. Occasionally going back the other way. So if you had 20 devices, then you'd have a bit of a cacophony. So this is not great code in the sense that it just cuts itself off. Note that we use this clear message, and this is a classic mistake. If you're ever doing something responding to an input that controls an envelope, you should always clear the envelope. Otherwise, the stuff you do here may not happen instantly. If there's already something happening on the envelope, if the envelope's already busy doing something which it hasn't completed yet, then these things will get added to the end of the queue, so they won't happen instantly. So if we want to make sure the envelope does its thing at the moment when an action is supposed to be happening, we should always clear it. That gets rid of whatever it's trying to do and any other future messages. So we've covered controller listeners and broadcast listeners and senders, and the idea here is that we've simplified a whole load of stuff you can do with OSC for communication within this network of devices. That's fine as long as you're happy just to broadcast within the device group, which is quite often all we want to do. In reality, there's a bit more to OSC messages than that. So this final example talks through how you actually build something from scratch. And again, this is using the SKIS library, which we borrow, which is available on GitHub. So in this code, we actually have to do the whole setup of the OSC system. And so unlike in the other two examples where the broadcasting and controller messaging are simplified, here we actually have to specify the protocol upon which OSC messages are sent and say a port. So the standard way you would work with OSC is you'd set up a listener. In this case it's actually called a server because it does the job of listening and sending messages. So it's an OSC server and it's instantiated with protocol and a port, and then we turn that server on. So at that point that server is listening on port number 5555. Any messages that come into port 5555, if they are OSC messages, will be sent to your code which will listen. So here we've created the server. Again, something that's a little bit more messy in this world is that there are exceptions being thrown, and so this code, the try and the catch block, if you don't know about those are to do with exception handling. And here we then add things that listen to our server, which is basically what we were doing earlier. We're adding a new OSC listener that adds some behavior, some function that you will call when the message comes in. So that's pretty straightforward. And here you're creating an OSC message and you're telling your server to send that message. And now in addition, we specify an address where we want to send that message. So this would be what's called a unicast message. It's sending to a specific network address. In our broadcast examples, it actually broadcasts it, it sends it out to everything that's on the local network to listen to. You can send a broadcast message by sending to a specific broadcast address. So this code basically does roughly the same thing as the broadcast sender and listener code. It doesn't have the clock, it just creates the message. You'll also notice if you look carefully in this code that we need, in much of the inbuilt HappyBracket stuff, when we call reset, we can be confident that clears out everything that has been set up. But actually some things that we might do in a HappyBrackets sketch introduce new threads. And so when we create this OSC server, it's actually starting a thread, it's running a separate process in the JVM. When we reset our sketch, this listener will actually still be running. So you have to do a little bit of overriding here of the reset function to make sure that we clear out that listener. It's not the end of the world if you don't do that, but you will actually find that you might have to restart your device because that's the only way to get it to behave as normal. So if you're ever getting really weird behavior on devices, one of the reasons for that might be that you've created an object that's persisting even despite the fact that you've reset. So I can recompile this. And by the way, this address is a standard IP address for localhost, which means basically yourself. It's called the loopback address. So that actually means myself. I can also say the word localhost here at that, and I'll just send this to this device, reset and send. And that's just played a bleep. Hard to see what's happened, but it's just played a bleep because at the same time as receiving the listener and setting up the listener, it's also received this block of code which tells it to send a message. So it's just sent a message to itself to play a bleep. So let's just recap. We saw the basic idea of an OSC message. An OSC message consists of two components. One is an OSC address, which you'll sometimes see referred to as a name, and that's a string. The other is a list of arguments. So there might be 0 arguments, there might be 1, 2, or more arguments. That's a variable length list. So here's an example. An OSC address has the name playtone with a /, and it's got the arguments 500, 1, and the string sign. Or more of a dummy example, the OSC address is /dinner, and the arguments are the strings fish, chips, and 500. So note that any word can be used, any string can be used. In fact, even a string with spaces in can be used. And we have the convention of using slashes, but we don't have to follow that convention. The arguments can be of any type. They can actually be of any class whatsoever, but typically we are mostly dealing with floats, integers, and strings, and then we take on the role of interpreting those arguments. There can be any number of arguments. It's your job when you receive an OSC message to check how many arguments it has before trying to interpret them, and to make sure you interpret them as the correct type. So the OSC message class that we use will know the types of those things, and you can pull them out. The main functions we looked at are adding a controller listener to HappyBrackets. We do that with the add controller listener function, and then we can add a new OSC listener. The add broadcast listener, which is exactly the same. The difference is the controller listener is only listening to messages that come from the controller, which is really only used for debugging or some kinds of live performance. The broadcast listener is listening for anything that's broadcast from elsewhere within the HappyBrackets network, including from yourself, so you can receive your own broadcast messages. And the broadcast message itself, HP broadcast, where we generate a new OSC message, and that's the message that will get picked up by the OSC listeners that are embedded in those other functions via the OSC listeners message received function, which looks like this. So we have an OSC listener, a new OSC listener with a message receive function which contains in its first argument an OSC message. It also has a socket address and a timestamp, which we haven't looked at, but the OSC message will be the thing that's being sent from the broadcast